everyone, we're going to consider the experiment in which a die is rolled 3 times. On each roll, the probability of getting a 6, which we're going to call S, is 1/6. And so the probability of getting anything that's not a 6, so that's going to be N, is going to be 5/6. So basically 1 minus 1/6. Or you could call this 6/6, which gives you the 5/6. So we're going to draw a tree diagram and create a table. And then we're going to also check 4 times. And for the 4 times, we're just going to do a table. So for the first one, let's draw the tree diagram. Let's spread it out here. So here's the first roll. And you're either going to get a 1/6, so that's for the 6, or a not 6 would be 5/6. Now those two add up to 1. So this is the first roll. The second roll, you can either get from this one, you're going to get 1/6, 5/6. So this would be your, if you get a 6 again, or if you get a non-6, you get a 1/6 the first time and a 5/6 the second time. And same thing for this one. So it's going to be 1/6, 5/6. So this is a 6 and a non-6. And then the third, so this is the second roll. So for the third, you do the same thing. So you're going to get 1/6, 5/6. That's for 6. And this is for non-6. And we just keep copying that down. And that's your tree diagram. One, 6, 5, 6. Then we just put 6, non-6, 6, non-6, 6, non-6. So when we do the table, I'm going to go ahead and write that this is the third roll. So the probability, say, of rolling all 6s would be 1/6 times 1/6 times 1/6. So you just multiply them through like this. And then if you roll non-6 and then 2 1/6, so we're rolling this one, then these two, that would be 5/6 times 1/6 times 1/6. So that would give you 5 divided by 6 times 6 times 6, which I think is 216. All right, so that's what we're going to do for the table. So here's the table. I already wrote it out. So to get all 3 6s, so it's 3 s's in a row, that's going to be 1/6 cubed. To get 2 6s, that means we're going to square. This would be the possible ways to do that. So each one of these has 2 of these 1/6. So there's 2 of the 1/6 there. All right. And then 5/6. But we have 3 of these. 1, 2, 3. So that's where the 3 comes from. Okay, if the 1/6, that means you only have 1/6 here. But the others, you have 2 5/6. 1, 2, 1, 2, 1, 2. And again, we have a 3 here. So there's 1, 2, 3 of these. And then for the 0 6s, everything would be 5/6 times 5/6 times 5/6, which would be cubed. And that is your table. Now we want to do make a table for the 4/6. We don't really want to do a tree diagram, but we want to do that. So basically, to get 4 6s, that's going to be 4 1/6 to the 4th power. Now what we're going to use, since we're not writing all these out, is we're going to use the Pascal's triangle to get our numbers. The ones we did earlier was this 3 one. Alright, so we were using this. This is part of the combinations. Since we're rolling it 4 times, we're going to use this right here. That way you don't always have to draw the tree diagram. So for 3 6s, what we're going to do is 4, let me do black here, 4, and I'm using this 4 right here, and that's going to be 1 6 cubed for 3 6, but the other one has to be 5 6. So that's to equal 1. These exponents should always equal 4. Okay, for 2 6s, now the next number we're going to use is 6. So that's 6, 1 6 for 2, so the 5 6 has to be 2. The next number is 4, so that's going to be, for 1 6, just put the 1, and the 5 6 is going to be 3, and 0 6s will just be 5 6 to the 4th. Notice that all of these are going to add up to 4. You could also put, if you want it, 5 6 to the 0, but that's a little excessive or redundant, so that's why we don't put it. Remember, anything to the 0 power equals 1. So let's take that back out. All right, and then lastly, this is an introduction video to binomial experiments. So let's talk about that. To have a binomial experiment and to do what we did using Pascal's triangle or combinations is there has to be exactly 2 possible outcomes for any trial. And that usually works for heads and tails. And our dice, you could either get 1 6 or you're getting 5 6. It's one or the other. There's a fixed number of trials. So we did our fixed number of trials. We did 3 trials. And the second time we did 4. The trials are independent. That means one doesn't depend on the other. That means we're not replacing anything like we do with marbles and stuff. And the probability for each given outcome is the same for each trial. These two kind of go together. So we either going to either get the 1 6 or the 5 6. And here's some formula stuff. You can look at that if you want to, but the main thing is to kind of know the definition here, because this is going to come in handy when you do probabilities. And that's it. Thank you. Have a nice day. Bye-bye.